Welcome to Lesson 129, Multiplying Fractions. Today we're going to talk about how to multiply fractions by whole numbers and how to multiply fractions by fractions. So if we talk about multiplication, we need to go back to the basics and think of what does multiplication actually mean. So when we talk about multiplication, multiplication is actually repeated addition. It's a way to shorten up a problem. So instead of having 3 times 4, this would actually be, since it's 3 times 4, that means we're adding 3 4 different times. So this is 3 plus 3 plus 3 plus 3. Another way that we can look at it is also to say, or we're multiplying 4, or we're adding 4 3 different times. So 4 plus 4 plus 4. These are one and the same. And it's the same thing when we look at decimals. This would be 5 and 6/10 plus 5 and 6/10 plus 5 and 6/10. Now instead of changing this and trying to do 3 plus 3 plus 3, 5 and 6/10 times, it's easier to do it this way. Since multiplication and addition can be switched around, we like to make the problems as easy on ourselves as we can. So I want you to keep this in mind when we're talking about multiplying fractions, because you'll notice your answer will actually be smaller each time that you multiply. And you have to remember what's happening is, yes, our number is getting smaller, but our pieces are getting to be more. So our pieces are getting smaller, but by making the pieces smaller, you're getting more of them. And I want you to think that when I'm showing you these pictures of how to multiply fractions, I'm making it easy on myself. I'm not going to try and draw 3 plus 3 plus 3 1/4 times. We're going to always draw the fraction and make that the repeated addition. All right, so if I take 3 times 1/4, instead of trying to add the 3 1/4 times, we're going to add 1/4 3 times, because that's what this problem actually means. What it means is we're doing 1/4 plus 1/4 plus 1/4. In this case, we know that this answer should be 3/4. Right? So same thing. If we're doing 4 times 5/8, how would we do that? Well, we know that this means that we're going to take 5/8 and we're going to add it together 4 different times. So we would have 5/8 plus 5/8 plus 5/8 plus 5/8. Right, so then in this case, we would get 20/8. If you've noticed a pattern, I think you have a pretty good idea of how to multiply fractions at this point. Otherwise, if you take a look at the last problem, and we have 3 times 1/4, and I ended up with a 3 as my numerator and a 4 as my denominator. And then over here, I did 4 times 5/8, ended up with 20 as my numerator and 8 as my denominator. This is because when we multiply fractions, instead of writing it out and adding all the fractions together all these different times, what you're actually doing is you're changing the 2 to 2/1, because these two things are equal. This is saying that I have 2 whole groups, but we don't know of what. So in this case, we're saying I have 2 whole groups of 1. So I have 1 in each group. I can always change my whole number to itself over 1 to make it an improper fraction. So now I'm taking the 2 and I'm changing it to an improper fraction so that I can multiply. So now I'm doing 2 times 5/6. Okay, and you'll notice if we did the addition, we would have 5/6 plus 5/6 give us 10/6. And in this case, if I multiply, 2 times 5 gives me 10, 1 times 6 gives me 6, so my answer would end up being 1 and 2/3 because 1 and 4/6 can be simplified to 1 and 2/3. When we're adding, we never add the denominators. That changes though when we're multiplying. So adding, never add the denominators. Multiplying, you have to multiply the denominators. But you have to be careful because if you're multiplying by a whole number, you need to make sure to change that whole number to itself over 1. Right, so I'm going to try the first one with you, and then you're going to have some time to practice 2 of them on your own. So in this case, I need to remember that it changes to 8 over 1 times 3/4. I multiply my numerators, and it gives me 24. And I multiply my denominators, and it gives me 4. So in this case, 8 times 3/4 gives me 6. Now what's happening here is since we're multiplying, I know my answer got smaller, and that seems silly, but our answer is actually, with fractions, yes, it's getting smaller, but it's because we're breaking the problem into more pieces. And think about a pizza. The more pieces you cut out in a pizza, the smaller those pieces get. So that's why your answer is getting smaller. You're getting more pieces, but as it goes on, those pieces are getting smaller and smaller and smaller and smaller. And also think as well, 3/4 is not a whole number. It's not a whole group. So you're not going to make the number bigger by multiplying it by something that is less than 1. Okay? The smallest that a number can be when you multiply it is itself, because the only number when you multiply it, but the only number that does that would give you itself, so that only number is going to be 1. Anytime you use a fraction, now your answer is going to get smaller than the number itself because this number is getting smaller. So what I'd like you to do is I'd like you to try these 2 problems on your own, and when you come back, we'll go over your answers. All right, so this had to change to 4 over 1 times 1/3, and that gives me 4/3, which I know is 1 and 1/3. Okay, and then for this problem, we would change it to 5 over 1 times 5/7. That gives me 25 over 7. 7 goes into 25 3 times. I have 4 pieces left out of 7. So my answer in this case would be 3 4/7. All right, so the same idea applies when you're multiplying a fraction by a fraction. You're still going to take your numerators and multiply them together, and take your denominators and multiply them together. So in this case, we know we're looking for an answer of 2/20. Okay, without simplifying that, I'm going to show you what's happening when we actually multiply fractions by fractions. So if I take 1/4, I'm going to take this whole right here, and I'm going to cut it into fourths and take 1/4. Okay, so I have 1/4 right here. Now I'm going to take that same whole and I'm going to cut it into fifths, going the opposite direction. So 1, 2, 3, 4, 5. But now here's the thing. It's no longer cut into fifths and fourths. It's actually cut into 20ths because we have 1, 2, 3, 4, 5 and 1, 2, 3, 4. So we have 20 pieces right here. And then we take the pieces that overlap. So we have 2 pieces that have blue and pink in them. And that's our answer. So we're taking that 1/4 and we're cutting it into fifths, and we're seeing how many we have that are the same. Now I know it looks like, oh, well then this is just 1, 2, 3, 4, 5, but you have to remember the pieces are getting smaller and you have to think of it as a whole. You can't think of it as just this one piece. You have to think of what would happen to the whole pizza, to the whole rectangle. Okay? And then we can simplify our answer and make it 1/10 because those two things are equivalent. Right? So again, if I were to do this again and take 2/4 this time, so I split my whole rectangle into fourths. Now, I'm only using 2 of them. You can't think of these things as 2 wholes because they're not a whole rectangle. They're only 2/4 of the rectangle. And I'm multiplying it by 2/5 of the rectangle. So now I have to split it and make it even smaller. In this case, I get 1, 2, 3, 4 pieces that were both cut into fourths and fifths, which would make sense because I have 4 on top. And I know that I got 20 pieces total. So my answer here would be 2/10. Simplified again would be 1/5. So now that you understand how this works, I would like you to take some time and I'd like you to try these problems on your own. I am going to post all 6 of these on Edmodo. I think that you guys are more than capable of doing them. If you have any questions, please be sure to post them to Edmodo so that way we can go over them in class.